Hello everyone, thanks so much for watching this video. I'm very excited about our new feature here in Geolitix. It's called Virtual Profiles. Now this is primarily intended for multi-channel users. Now theoretically you could use this with a single channel project if you had data that had sufficiently high data density. We're talking about profiles that might be 10 centimeters apart, which sometimes happens with archaeological projects, but really the big advantage is for folks using multi-channel systems. So just to make sure we're all on the same page, multi-channel or array GPR systems are ones that'll have 4, 8, 32, sometimes up to 50 channels that are all lined up in a row and are usually towed behind a vehicle or on some sort of large pushcart system. And they essentially image in very high resolution swaths that are anything from 70 centimeters up to about 2 meters wide. And they produce exquisitely high definition GPR images. Now, the challenge is, what do you do with those images? Of course, we can migrate the data and we see all our pipes or our archaeology very clearly, but we want to make the maps that we produce as accurate as possible. And we already know in GPR that there's so many sources of inaccuracy, be it GPSs that aren't exactly as accurate as possible, latency issues, inaccurately positioned total stations, or even not accounting for velocity variations. So there's lots of opportunities for inaccuracies in GPR. Let's not make mapping our pipes once we have the data into the software an additional source of inaccuracy. So let's take a look at a data set. I have a data set up here right now on my screen that comes to us from our friends at Impulse Radar in Sweden. I think this is actually collected in somewhere in the United States. It looks very American. I can just tell from the road. And let's zoom in on it, right? So we have some very, very clear pipes here. Now, this data we can see as we hold down our Alt key, we can see all the individual channels. And so it was done along the direction of the lane. That makes sense, obviously done with a vehicle. We can see here that there's probably been a parked car that they had to go around. But wow, the clarity of the signal, the clarity of the resulting slices are very, very good, right? So we can see all the perpendicular pipes very clearly because, of course, the radar crossed over them and we formed a very nice hyperbola. Now, with 3D migration, which is a very important tool with multi-channel data sets, we can see the pipes that are parallel to the direction of travel very clearly as well. So we have at least 3 of them here. And as we scroll up and down, I have a bit of a thick section here. So as we scroll up and down, you can see them come in. Oh, actually there's 4 or 5 of them. Great. Okay. But let's say, okay, let's pick the second one here, right? The one that's really clear. If I actually tighten up my slice thickness and make it, well, essentially nothing. So now this is individual slices. As I go down, I can see that this pipe is closer to the surface right around this area than it is at a deeper depth. So in other words, this pipe seems to bow upwards somewhere near the middle. Okay, now, how are we going to accurately, we can do the X and Y very clearly. We can see where the pipe is, but how do we know the exact depth of that pipe as we go along the street? Well, this is how we would do it traditionally in Geolitix. We would add a new feature called a polyline. We'd give it a color that I can notice, and then I'd go along essentially and tag a couple of these points, and maybe, maybe I'll try and raise it a little bit so the polyline tool knows what depth the slice is at, right? There's my polyline. Okay. Now, that's okay. That's pretty good. But there's got to be a better way of doing this, right? Because the one thing we all have to remember is as soon as you migrate something, the clarity, the precision is gone, right? That beautiful hyperbolic shape that we see from the reflection from a pipe becomes a big black blob. And well, where's the center of a blob? Well, where's the center of a cloud, right? That's a difficult thing to answer. So I'm going to delete this and I'm going to show you our new way of doing this. So I'm going to take this slice right here and I'll see if I can zoom in a little bit here. I'm going to try and get as close as I can. I'm going to right click and I'm going to say Start Virtual Profile. I'm then going to drag that across and click here, Finish. So now I've created a virtual profile along the section of that pipe. I can see very clearly where that is. Now I can draw it on the screen as a horizon, as a bunch of points if I wanted to, but even then, is that the best way of doing it? Right now, you know, my eyes are bad, I'm getting old. Did I really get it on top dead center of that pipe? Is it really in the middle of that black line? Kind of. I did the best I could, but maybe not, right? So what are we really looking at here from a geophysical standpoint? Well, okay, let's use this piece of paper as an analogy, right? This is our hyperbola as we cross that pipe. But really, it's like this, right? This is really what it looks like. Now, okay, I don't have enough hands to show you, but you get the idea here, right? So what I wanted to do is run a virtual slice along the very top. But man, how am I going to do that? That's really difficult to see, and particularly with GPR, because, you know, the car wasn't driving exactly on top of the pipe. The car was probably weaving in and out of the lane a little bit. It's never exact, right? So drawing a straight line becomes really difficult. So what you end up happening is, you know, you're off to the side a little bit, or you've kind of, the pipe goes like in and out and you're kind of cutting in and out. There's got to be a better way. So take a look at this. I've already drawn my virtual profile. Now what I'm going to do is say, instead of single line, I'm going to pull down to cross sections. And take a look at this. So now I can define the width of my cross sections and the step size. That is what the distance is between each cross section. So this allows me to create, essentially, let me just make this a little bit bigger. I can now, and I'll zoom in here, I can now really tag the top of the hyperbola, and I can see the original hyperbola without all the masking and the blurring effect of migration. So look at this. Here it is. Okay, I'm going to go in. Now I can do this a number of ways. I can make them points if I wanted to. Let's make that an obvious color here. There we go. So I can add a point to this, or, okay, let's forget about the point. There's a better way of doing this. Let's actually draw a polyline directly on our cross sections. We'll make it a green, I guess. Okay, here we go. So click, that's about as good as it's going to get. And then I just go to the next one, and here it is. It's got to make it, of course. There it is. Oh, wow, that one's really clear. So this enables me to get much better accuracy. And, you know, at the end of the day, if there's like, which one is it, right? There's a couple of them there. I'm going to go with that one. If there's one cross section that it's not very clear for whatever reason, there's a little bit more water in the soil, the radar absorbed a little bit more, that's okay, skip to the next one. At least what you're generating here is as accurate a depiction of that pipe as you can possibly get. So this is one of the tools that we wanted to add to our platform for the last few months, and we've really been working hard to get it, tweak it right and get it done in a useful way, but add some features like these virtual cross sections that really give the user a much more power in delivering a accurate final map. So guys, thank you very much, and as always, reach out with comments, questions that you might have about the platform. We're always here and we're always interested to hear from you guys. Thank you so much.